What is going on, y'all? In this video, we are going to learn some of the applications. And I'm just going to say some. There's a lot of applications of this stuff. These are just some of the more common ones of exponentials and logarithms. So let's go ahead and look at our first example. So we have a depreciation question. This is going to fall under a category. This category is simple growth and decay, like Donkey Kong. All right, simple growth and decay. And there is a formula for this. This is A times 1 plus or minus R to the T power. All right. So you're going to use plus if you're growing. Sorry, y'all can't see that. If you're growing, you're going to use plus. If you're decaying, you're going to use minus. And then A is going to be your starting value. All right, so let's go ahead and take a look at this problem. Oh yeah, and T's the time. So let's go ahead and take a look at this problem. The value of a car decreases by 20% every year. So decreases, this means we're going to use minus. By 20%, here's our rate. So our rate is 0.2. I bought my car, so I bought, that means it's the start, in 2014 for $17,000. This is true. So this is going to be our A. About how much could I expect to resell it for? So I want to know the price right now. After, let's say, 6 years. So if I were to resell it right now, what would I resell it for? So let's set up our equation. We have 17,000 as our A value, multiplied by 1 minus, because this is a decreases by 20%. And our rate is 20%, so we have 0.2. And then T is our time. So we have 6 years because it's 2020 right now. And if I bought my car in 2014, that's 6 years ago. So let's go ahead and calculate the value of this. So we have 17,000 times 0.8 to the 6th power. Now, I have no clue what 0.8 is to the raised to the 6th power. So let's go ahead and put it in the calculator. We have 0.8 raised to the 6th power. So it's that number. And then we have to multiply this by 17,000. So $4,456. Thank God that car values don't actually depreciate by 20% every year. At least I think they don't. Maybe they do. I made this problem up. So $4,456.45. So there's our answer. Simple growth and decay. All right, let's go ahead and look at the next question. All right, so we had a simple decay problem, and now this is going to be a simple growth problem. So let's read it to you. T is the another way to say AT&T stock. It's expected to grow 5% per year. That's not true, just for the purposes of this problem. Of one share of T was $33 in May of 2017. How much should it be worth right now? So let's go ahead and read this in math terms. We have grow. So this is going to be plus. 5% is our rate. So rate is 0.05 per year. Okay. If one share of T was $33 in May of 2017. Okay. So T is equal to 3 because that's 3 years ago. This is going to be A is equal to 33. It's our starting value. How much should it be worth now? So let's go ahead and do this. So it's going to be worth now, let's say P is equal to 33 times 1 plus, right? It's growing. Our rate is 0.05. So, and then raised to the t power. So this is, remember, this is a times 1 plus r to the t. All right, so now we need to calculate this. So P is equal to 33 times 1.05 raised to the third power. Let's get our calculator out. 1.05 raised to the third power. And then this times 33. So 38.20. It's a pretty good increase. 38.20. This is not how stocks work. I'm just going to make that disclaimer right now. So, yeah, 5% per year guaranteed. Yeah, no way, buddy. All right, let's go on to the next question. All right, so here's the other type of application we're going to learn. It's going to be compound interest. So in this case, our formula is going to look quite interesting. Remember, actually, you know what? I'll do that in a second. So the formula is going to look quite interesting. We're going to have the final is equal to the principal. This is the original amount that you put in. The principal times 1 plus the rate over n raised to the nt power. So n is going to be the amount of divisions in a year. All right, and what I mean by that, hopefully that'll be clear in this question. So let's go ahead and read this. You put $1,000 in a high yield savings account. Well, if you put $1,000, that's going to be your original. So that's P. Okay. And it has an annual percentage something yield, annual percentage yield. I think that's what APY stands for, of 1.7%. All right. This is R. So R is our yearly or annual rate. So R is going to be 0.017. All right, the interest compounds monthly. All right, so monthly, N is the amount of times you compound in a year. So if it's monthly, let's see. If it's monthly, then N is equal to 12. Let's see, you also got, you get semi-annual. That's N is equal to 2. You get quarterly, which is quite common actually. This is N is equal to 4. Monthly is N equal to 12. You can have daily. So, we got 365 days usually. And what if you had hourly? What if it compounded hourly? That would be 365 times 24. So it's getting bigger. Remember, the smaller the division, the bigger the N's gonna get. Yeah. So we're gonna come back to this. All right. But these are gonna be some common ones. Hourly is not common, but up to daily. All right, so it's monthly. So we're going to use N equals 12. Okay, how much will you have in 2 years? So T is equal to 2. T is the time in years. All right, so let's go ahead and calculate this. So F. I just use F for final. I don't know if that's what most people use. Is equal to 1,000. That's our principal. We found that. Times 1 plus our rate, so 0.017, divided by N, which is 12 raised to the nt power. So we have 12 times 2. Alrighty. So let's go ahead and calculate this. First, I need to know what this fraction is. So let's do 0.017 divided by 12. So 0.0014166667. Okay, cool. And now I'm going to add 1 to this. So this is what's going to be on our inside. All right. So 1,000 times 1.001416, repeating. And then 12 times 2 is 24. So next, what you don't want to do is round, because when you're talking about money, people will take every penny from you if they can. So don't round until the end. We're going to take this number and then we're going to raise it to the 24 power. All right. And then we're going to multiply this by our principal, 1,000. And we are at $1,034.56. You know what? Not bad. That's really good. So $1,034.56. That's actually really good. See, our annual yield was 1.7%. So if we didn't have any compounds, then we would have gotten $1,017. We would have gotten $17 in interest. But since it was compounded monthly, we actually got double that interest. We got $34. So that's actually kind of a lot. You can think, if you're putting like tens of thousands of dollars, and then how much it compounds actually matters. Actually matters kind of a lot. So that's compound interest. Let's go ahead and take a look at continuous interest. So I don't have a problem written down here, but we're going to make one. And the reason why I don't have a problem down here yet is because I want to show you where this comes from a bit. So if you take a look at our compound interest formula, we have, spoiler, we have our principal times 1 plus r over n to the nt. And remember when I said, the more compounds you have, the more compounds, then n gets bigger. And what happens? What happens whenever n gets bigger here? Well, this fraction gets really, really small. Or you know what? We could say n goes to infinity. So if you remember, e is this fraction whenever n is going to infinity. This is e. So maybe we have e here somewhere. And if you thought that, then you're a I was going to say genius, but then I stopped. I don't know why I stopped. All right, so this is the formula for compounds continuously. It's your friend PERT. Don't forget it. I haven't forgotten PERT. A lot of people haven't forgotten PERT. It's one of those things that you just don't forget. Kind of like SOHCAHTOA, except this time it's PERT. All right, so let's think about a question like this. Let's say you have $4,500. You invest $4,500. It compounds continuously. And it's going to be at a rate of 2%, which is really good. And you're going to want to, let me teach you some more vocab. This is your time horizon. So that is how long it's going to be until you take this money out. Your time horizon, let's say, is going to be something like 15 years. All right, so we're putting $4,500 into a savings account, compounds continuously at a rate of 2%, which is really good. And then you're going to take it out in 15 years. So we're going to want to know how much money we're going to have in this account after 15 years. Let's go ahead and do it. So we have 4,500. Oh my God. Times E raised to the RT. So R is 0.02 and T is 15 years. So let's go ahead and simplify this. 4,500 times E to the 0.02 times 15. That's going to be 0.3. Let's go ahead and plug this in the calculator. All right, so here's my calculator. I think we should have an E to the X. There we go. So let's go ahead and clear all this stuff. So E raised to the, sorry, not that. You have 0.3 and then say E to the X. It's going to be about 1.35. Okay. So now we need to multiply this by our principal, 4,500. So we get $6,074. That's pretty good. $6,074. And don't forget the cents. So 36 cents. All right, y'all. I know this was a super long video. I don't know why it went so long, but maybe I just got distracted. But anyways, I hope you have a good rest of the week. Be good. And yeah, that's going to be it. So see y'all.